Okay, guys, the second recording is on sound waves. So we're going to select sound, click on that. And so down here at the bottom, you can toggle between water, sound, and light waves. So we've selected sound. Okay. And with sound waves, first thing you want to do is hit the green button, and that will turn the sound on. Okay. Now, to hear the sound on your computer, what you need to do is go over here and select the play tone box. Okay, so you can turn the sound on and off. If you have your speakers turned on your computer, you'll be able to hear it. Now, when you do the work, when you answer the questions, you probably want to leave the tone on so you can actually hear what's going on with the sound waves. I will be turning it on and off. I will be turning it on and off just to make this video a little easier to understand. Okay. Let's look at some other things that we need to do. Take your wave sensor, just like with the water waves, and we're going to set that up. Once again, I would just recommend using one of the sensors, so you get a nice, clean, single wave form. Okay. Now, another important thing that you can change with sound waves is the way you view them. You can view them as waves, as longitudinal waves, but remember, sound really isn't a longitudinal wave. Sound is a compressional wave. A lot of times we view it as a longitudinal wave just to make it easier to draw and easier to understand, but what it really looks like is vibrating particles. So sorry about that. If you click the particle button here, now you can see what sound waves would actually look like. They're particles vibrating. You can see here you can see clearly the compressions and rarefactions as the speaker produces a sound. Now, let's look at what you're going to do to answer your questions. Let's click it back to waves, and we're going to play the tone. And the first thing we're going to do is we're going to change the frequency of the tone. Okay, so the first thing I'm going to do is reduce the frequency. Notice that the wavelengths have gotten longer, they're spread out, and the pitch of the sound is lower. Okay? Now, if I move the slider the other way and increase the frequency, you'll notice that the pitch gets higher and the sound waves the wavelengths are shorter. Okay? The crests are closer to each other, the troughs are closer to each other. It's a shorter wavelength. So explore that a little bit, changing the frequency. The other thing that you want to explore, and you'll need to do to answer the question, is to change the amplitude. Amplitude is how much energy is there, and that would be how loud the sounds are. And you can look at that as waves, and you can look at that as particles. Okay, let's just switch it to particles for now, and let's reduce the amplitude so the sound is quieter. And notice that as the sound gets quieter, the compressions and rarefactions are not very distinct because it's a quiet sound. Okay. Now let's increase the amplitude. Okay. So now you can see that the height of the sound, the height of the wave is much greater. There's more amplitude, and you can see that the compressions and rarefactions are very distinct. Now I'm going to turn the tone off. Okay. And just a couple more things. Notice that the top view and the side view don't really make much difference for sound waves because sound waves occur in a three-dimensional space. So it doesn't really matter whether you're looking at them from the top or the side. One other thing that you can do with sound is that you also have a pulse function, just like we did with water waves. So if you click here, what will happen is that you can create just a pulsive sound instead of a continuous sound. So let me, I'll turn the tone on and I'll push the button. So every time you push the button, you get a little burst of sound, and you can see how that reverberates around the room. Okay? Or actually propagates through the room. It doesn't really show echoes. Okay, so that's what you need to know. Now the next video will be about light.